You may have noticed that talk and discussions play a big role in OpenSciEd units. But why? Well, the reason is because we know that the ones doing the explaining are doing the learning. When I first started teaching, there were topics that I didn't feel as comfortable with, ones that I know I had learned at some point in my science background, but that I didn't sort of own in a way that I could easily explain or talk about. And over time, I ended up understanding those ideas way more deeply because I got lots of practice talking and creating explanations. I was the one doing the explaining and therefore the learning. And you've probably experienced this yourself when the act of trying to explain something actually helps you develop a deeper understanding of it. Sometimes this is called the self-explanation effect. The more I get an opportunity to explain, the more I understand it. That self-explanation effect is true in general, but it's particularly important when what we are trying to learn is way more complex. The thinking we're asking students to do is different. Trying to explain how and why a mountain can move is different than defining the 3 types of plate boundaries. And so when we shift from just learning about ideas to the kind of deep sense making that's required to explain phenomena, students need lots of opportunities to explain and ask questions and fumble ideas and hear what others are thinking. But not just any talk supports this kind of deep learning. If you asked me back when I was doing all the talking and explaining if my students were talking, I'd say, yeah, they talk all the time. But usually it was towards an idea that I had just told them, not something that they actually needed to figure out. The reality is that often the talk we ask students to do isn't really needed to make sense. We ask kids to give answers to questions that other students and the teacher already know. Sometimes we call this guess what's in my head. And to complicate matters, it's really common in these guess what's in my head discussions that only those who know the right answer get to speak, and those that aren't sure or maybe have a partially formed idea won't have a chance to talk. If students need to talk about something regularly to understand it, then students who aren't getting a chance to share won't develop their explanations. So what does this look like in an OpenSciEd classroom? In OpenSciEd, students have lots of chances to talk about how and why something happens. They'll talk with a partner or in a small group or sometimes in a scientist circle. And the important thing here is that in all of these situations, there's something compelling to discuss and figure out. If students are asked to discuss something that they find puzzling, like, wait, do all things bend when they make a sound? They're likely to be more motivated to participate. Additionally, in OpenSciEd, where we're focused on figuring out some pretty complex phenomena, students actually need the thinking of others to help them figure out what's going on. Another really important thing about talk in OpenSciEd is that there's a focus on building a culture where students feel safe sharing their ideas. Supporting this type of talk might feel hard because it might feel different for both you and your students. But on the OpenSciEd website, we have lots of tools and videos that will help you support your students in discussions, so be sure to check those out.